So let's take a look at 11.4 now. So this might be a little more tricky. True-false questions. A chi-square test for independence was done to see whether the type of salad dressing people order at a restaurant and the type of meat they order are independent or dependent. If the p-value was found to be 0.02, then at a 5% level of significance, it can be concluded the dressing type and meat type are dependent. Is that true? Or is that false? How do we go about figuring that out? So I think the easiest thing, so you know we're talking about a test for dependence. Write on your exam 4 notes, number 11, I would just write out the HO and the H1. HO is always independent. H1 is always dependent. That's what it says right on your exam 4 notes, number 11. We know they're talking about a test for independence because they said the word dependent right at the end. So it's HO independent, H1 dependent. And what's our p-value? They said p-value is 0.02. And that is clearly lower than a 0.05 significance level. So that p is low. So what does that mean you do when the p is low? HO must go away. See, you know all that real well now. So we cross that out. So does that mean they're dependent? Yeah, that's what's left, huh? So yes, true. See how easy that is if you just write the HO, H1, and you know the P is low, so the HO must go. Cross out HO. HO is always independent on dependence tests, and H1 is dependent. So that's easy. They're just seeing if you can track through that. So that'd be true. How about number 2? Last year, 34%, this is Lake Tahoe Community College students, considered math to be their toughest class. 25% thought it was English, and 41% said it was something else. A researcher wants to conduct a study to see if these proportions have changed. The researcher should conduct a chi-square test for independence. Is that true? So now they're going to make us think about these different tests we've learned. This is often part of the trickiest, this is one of the trickiest elements here. How do you think that's valuable though? Suppose you have this real life question and you're thinking, what kind of test should I do? What kind of test should I conduct to see if this is true? Would it be a chi-square test for independence? Is that what we're trying to figure out? If two things are independent? Do you understand what they're saying? They're saying 34% thought math. So they're saying math, 34% thought that was their hardest class. English, that was 25%. And other, that was 41%. Now then they want to see if later, if it's changed. Like that was a couple years ago or whatever. So they're saying later, like 2 years later, 5 years later, whatever, has it changed? Or do you think it's, after 5 years later, do people still feel if they, surveyed the students 5 years later, would the new group have the same percentages or, different? What kind of test is that? Is that chi-square test for independence? No. Do you know what kind of test is that? What is it? A what?
Homogeneity? Is that...
Homogeneity?
Yeah.
It's actually not that one either.
Is it goodness of fit?
It's goodness of fit. You're seeing if the new percentages fit the old ones, right? That's what you'd be doing in the test, huh? You'd be going in there saying, okay, I'm going to find out the new math percent, the new English, and the other, and I'm going to see if it fits, meaning if the percentages are about the same or not. That's a GOF test, goodness of fit. That's the kind of test you would set up. Does that make sense? You're seeing if a bunch of percentages match. So no, false, it's not a independence, it's not a homogeneity either. I could see where homogeneity, you would think so, because that's sameness, huh? That means sameness. And aren't we trying to feel if they're the same? But it's sameness between two variables. Notice you've got to have two variables, right? Like this one up here. We were talking about salad dressing and type of meat. So that was, independence or homogeneity. Whereas this one, there's not two variables we're talking about. It's just percentages in categories. That's goodness of fit. See that difference? Homogeneity is questions like, for the various genders, men and women, do they have the same pass rates in math classes, stats class, or whatever? That would be sameness among gender and pass rate. Two variables. Get that? That'd be homogeneity. There's not two variables here. There's just a list of percentage categories. That's goodness of fit. Question 3. A researcher wants to see if the blood type of geniuses follows the same distribution as the blood type for the general population. Then it would be appropriate to use a chi-square goodness of fit test for this study. So the blood types. Now, what kind of blood types are there? Well, there's A, B, AB, O, and there's positive for all those, and then there's negative for all those. A, B, AB, and O, and negative for all those, huh? So there's 8 different blood types, and, what percentage of people have A positive? I don't know, 10%, 12%. I'm just guessing, totally guessing. I have no idea. But there's some kind of percentages for the general population, like everybody. And then they're wondering if we took geniuses, like super smart people. I don't know how to spell geniuses. I'm not a genius. Okay. Yeah, I got it right. Would the percentages fit? Well, I just said it. Huh? I just said it. It's a fit question. It's another goodness of fit. I can't help but say it. It's goodness of fit. It's not. Oh, did they ask that? Yeah, they're right. Goodness of fit. True. It's a goodness of fit. You're seeing if the genius's blood type percentages fits the general population. Does that make sense? I saw some geniuses today I got a link from a colleague that there's been some new discovery in math science thing. Anyway, I won't bore you with the details. Something they discovered. They showed a picture of the 3 people that discovered this it's a physics thing that has a math part to it. Anyway, they discovered it. They're working at these national laboratories, and they showed the picture of them. I'm experiencing this increasingly now that I'm 52. They showed the picture, and I go, "They're a bunch of kids." That's how everybody looks to me now. They're a bunch of 29-year-olds probably. Nah, they might be in their 30s. But anyway, those kids figure that out. Yeah, those are smart kids. On we go. So it's goodness fit. Next one, number 4. Researcher used a chi-square test for independence, where the 2 variables were favorite color and color of car owned and p-value that was produced. Then the researcher can conclude, blah, 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 dependent. Is that true? We'll just do exactly what we did a minute ago. So they're talking about a test for independence. So you know how that goes. Right on your exam 4 notes, it says HO is always independent. H1 is always dependent. And the p-value came out like super low. That's certainly lower than any significance level. So that's certainly lower than 0.05. So the p is low. The HO must go away. So cross out HO. So what's the conclusion? Dependent. Is that what they said? They did. True. Same as the other one, huh? Good and easy. Next one, question 5. If a researcher is interested in determining if there's a relationship between favorite color and college major, then a chi-square goodness of fit test can be used. Is that true? Is there a relationship between favorite color and major? Like, do people that like blue better, do they tend to pick history, liberal studies? People that like green, they're more into sociology and anthropology. Is there some kind of relationship there about your favorite color and the major you pick? Probably not. But if we wanted to statistically research it, how would we research it? Would it be a goodness of fit test? Not at all. So you're getting the idea that the independence is what you'd want to do on this one. Independence compares 2 variables, doesn't it? And so does homogeneity. Basically the same thing. Homogeneity and independence. They're really the same. That was 11.3 and 11.2. They compare two variables. Whereas goodness of fit, that's a bunch of categories with percentages. It's really just one variable. So this is false. It's not goodness of fit to compare two variables. It's independence or homogeneity. Is this good? We'll move on if you're good. So comparing two variables, that's what, if you're doing some kind of study and you want to see if there's a relationship between like favorite color and major, that's an independence test. See if those affect each other or not. Two variables. Whereas goodness of fit it's a different deal. It's a bunch of categories as we've seen, right? This was goodness of fit back here. Blood type for general population and the geniuses. That's goodness of fit. All right, on to number 6 we go. A researcher wants to determine whether the town's citizens' political affiliation has changed since last year. The distribution from last year is known, and the researcher will be surveying 2,000 of the town's citizens. The researcher should use a chi-square test for goodness of fit. What are they trying to figure out? Wants to determine whether the town's has changed since last year. Like how many are Democrat, Republican, Green Party, other. So, they have some kind of percentages, right? Maybe 55%, 44%, 1%. I don't think those add up. I messed up. Whatever. 54. 40, I don't know. Whatever. I'm probably way off. Whatever. Anyway, is that a goodness of fit?
Yes.
For sure. That's goodness of fit. That makes sense. You got one variable, political affiliation, and you're testing it, comparing it, seeing if it fits. So just one variable, political affiliation. As opposed to like two variables, favorite color and major. That's chi-square goodness. That's a independence test or homogeneity. Whereas goodness of fit is one variable comparing two situations. See that? Number 7. A researcher wants to determine if the every county, this is an awkward sentence. Researcher wants to determine if, get rid of the other, if every county in the state has the same high school dropout rate. The researcher should use the chi-square test for independence for this study. So think about what they want to do. They want to go county by county. Like they want to take, every county. They want to, I don't know what the different counties are. Butte County. And they want to say, what's the dropout rate? 29%. They want to do Fresno County. What's the dropout rate? Maybe 30%. Tulare County. What's the dropout rate? 28%. On they go. So they want to take all those counties, find out the dropout rate, and find out if it has the same, if they all have the same dropout rate or different. So are we comparing two variables? I think we kind of are. This is not easy for me either. County and dropout rate. Right? County is the first variable, like what county you talking, and dropout rate is the second variable. And we're wondering if it's same county by county. Same homogeneity. That's a test for homogeneity, not independence. Right? Not independence. I hope I'm right on that one. Am I? Okay. Did you click the button? Did it say it was? And did you click the reason button? Do they have a button there that says explanation or something? So that would be a test for homogeneity on that one. All right, we'll move on. See that difference? All right, that was a close one. Question number 8. Chancellor to College District with 14 colleges wanted to see if the specific college that a student attends is related to student's major. So college that you pick, college picked, and major. Like if you want to do a certain major, I already forgot what you did, not biochemistry, molecular biology. You pick a certain college, not Chico or Humboldt. All right. Does the college picked and major, does that relate? Probably, huh? Anyway, is that a independence test? Yeah. We're trying to see if those are independent or dependent. That's the kind of test, huh? True, that's exactly the kind of test we would do. To see if one of those variables affects the other one. And they probably do. Now making sense? Getting the hang of this? You can pick out which study affects which thing. How about number 9 there? If is it on the screen? Yeah, barely. If a researcher is interested in determining if there is a relationship between ethnicity and job type, then would that be a goodness of fit test? No, whenever you're doing 2 variables, it's not goodness of fit, huh? Goodness of fit is just one variable, like political affiliation or blood type, right? This is 2 variables, job type and ethnicity, so it's certainly not goodness of fit. It would be independence, wouldn't it? Seeing if those affect each other or not. That would be an independence test. Is this making more sense then, how these different tests work that we've learned? So independence is seeing if 2 things affect each other, 2 different variables, like the type of job you have and your ethnicity. And then goodness of fit is one variable, like blood type or political affiliation. Number 10 is the last one. Number 10. A researcher wants to determine if the racial distribution of America's automobile employees is the same as the racial distribution of America. So, in other words, we're talking about America, and how many are white, Asian, da-da-da-da-da-da-da. And then we're talking about automobile employees, those working for a car company. What's the percentage that are white? What's the percentage that are Asian, etc., etc.? So they want to compare those 2. Should that be a chi-square test for independence? No, what is it? Goodness of fit. That's false. It's not independence. It's a goodness of fit. You're seeing if those 2 things, right? Just one variable, and that is ethnicity, right? That's the only variable, ethnicity. Comparing 2 groups. So is that good? Questions on that? Like you could do that kind of thing on a test? I gave you 3 or 4 of those. You could do the true-false thing.